Okay, so for number 1, it says Eddie's Towing Company charges $50 to hook a vehicle to the truck and 90 cents for each mile the vehicle is towed. Write an equation to represent the relationship between the number of miles towed M and the total charges C. So right here, I definitely have a beginning amount and a slope. So we're going to use slope-intercept form, y equals mx plus b. And they do give us variables, but I'm going to start off by using x and y. I know that I'm looking at the number of miles and the cost. My independent variable is going to be the number of miles, and my dependent variable will be the cost. The next thing I need to find are my slope and y-intercept. So I have 90 cents for each mile, and I have $50 just to hook a vehicle. My slope always has the word per next to it. So this 90 cents, that's my slope. And this $50, that's the beginning amount. So even if we go 0 miles, they're going to charge me $50 just to hook up my vehicle. So my equation is going to be y equals, and it's going to be 0.90x plus 50. I have my slope next to my x, and I have my y-intercept. Now they told us that for the number of miles, instead of using x, they want us to use m, and instead of y for the charges or for the cost, they want us to use c. So we can just rewrite this really quick, and instead of y, we'll put c, and instead of x, we'll put m. Essentially, it's the same thing. We're just changing up those variables a bit. And we're all done. Number 2, it says you talk on the phone y minutes on day x of every month. So I'm going to make a note off to the side again. So y is minutes, x is day of month. So we're using the equation y equals 2.5x plus 2. The cell phone company claims you talk 12 minutes on the phone on the 4th day of the month. Are they right? Well, let's see how many minutes we talk on the 4th day of the month. So I'm going to write y equals 2.5x plus 2. Now, I know that they're talking about the 4th day of the month. So that's actually what I'm going to use. I'm just going to plug in 4 for x and see if it gives me 12 for y. So we're going to say y equals 2.5, the 4th day of the month, plus 2. Now when I plug that into Desmos, I get that y is equal to 10 plus 2, which is 12. So what this is saying is that when x is 4 on the 4th day of the month, y is 12 minutes. So yes, they are right. On the 4th day of the month, if we plug it into our equation, we get 12. So number 3 says in 1999, there were 80 laptop computers at Grove High School. Starting in 2000, the school bought 20 more laptop computers at the end of the year, or at the end of each year. The equation t equals 20x plus 80 can be used to determine t, the total number of laptop computers. Oh, that's important. They're telling us what the variables are. At the school, x years after 1990. What was the total number of laptop computers at Grove High School at the end of 2008? Okay, so they want to know t, the total number, when x equals, okay, how long after 1999 was 2008? We are going to end up getting 9, which means that our x is going to be 9 years because it has been 9 years since 1999. So we're going to do t, trying to find t, equals 20, but instead of x, we're going to use 9 plus 80. If you don't know where this is coming from, it's from the equation that they gave us right here. Okay? All I'm doing is I'm replacing x with 20, or 9 years. So let's see, after, what is t going to be then? So 20 times 9 is 180 plus 80. So the total number of laptops is going to be 260. And again, we know that t is the total number of laptops. So this is going to be 260 laptops. And that is, of course, in 2008, 9 years after they started in 1999. Okay. Number 4, if the function f of x represents the number of hours it takes a person to make x dollars, then what domain makes sense for the function? So we're looking at the domain. We know that domain is x, and it tells us right here that we're making x dollars. Now, the way that they word it, it sounds like they're making money. So their amount of money is going up. So they are actively getting money. They're not losing money, they're making money. So it's not going to make sense for them to be making negative $5. So in this case, the negative money does not make sense. So we know that the money can be, we'll say between 0 and infinity, because we don't really have a top. So right here, the best one is going to be C, because they're not making negative infinity dollars. B says x is less than or equal to 0, which would be all negatives. That doesn't make sense. And D says x is greater than infinity. That doesn't make sense either. So the only one would be C. Okay, the next one says Barbie trains for a 10K each week. She writes the function to model the relationship between the number of weeks W she trains and the distance f of W in miles she can run. What does the slope of the function represent? Well, we're looking at two things. We're looking at weeks and we're looking at miles. Now we know time is always going to be our x, because that's going to be independence, and y will be whatever's left over. Well, remember that your slope is always going to be the y's over the x's. So we're going to end up saying miles. It's always going to be the word per or each. Miles per, and then your x. So your y comes first. This is your y, the unit on the y, per your x. So the function, or the slope is going to represent miles per week. And in this case, the slope is 0.7. So we can get more specific and make our final answer 0.7 miles per week. Okay. Number 6, find the equation of a line parallel to 6x plus y equals 10 that passes through the point -8, -8. Well, we know that if lines are parallel, they're going to have the same slope. So let's go ahead and find the slope of the equation that they give us, or of the line that they give us. We have to get y by itself because right now it's in standard form. So we're going to subtract 6x to both sides. And we get y equals -6x plus 10. And now y is by itself, so we can go ahead and pull our slope. Remember, the slope is always going to be in front of x. So we know that since the two slopes are parallel, both slopes are going to be -6. So now since I have a slope right here and I have a point, we're going to plug it into the point slope formula. It is on your reference sheet, but I will rewrite it right here. Y minus y1 equals mx minus x1. So we're going to have y minus, the y value here is -8, which will turn into a +8, equals our slope is -6. X minus, again, we have a -8, turns into a +8. I'm going to zoom in so I got a little bit more room to work. I'm going to turn this into slope-intercept, so I'm going to go ahead and distribute. You get y plus 8 equals -6x minus 48. And then we can subtract 8 to both sides. Put my line down the middle. We can subtract 8 to both sides. And we end up with y equals -6x minus 56. Okay. Number 7, now we're going to do a perpendicular line. So perpendicular slopes are going to be opposite reciprocals. So the line that they gave us is actually already in slope-intercept form. So right away, we know that the slope of the original line is going to be positive 1/2. Well, remember, an opposite reciprocal is going to be changing the sign, so now it's a negative, and flipping the fraction. So our new slope is going to be, so I'm going to put new. Our new slope is going to be -2. That's the one we're going to use. So again, we'll plug into point slope form because now we have a point and we have a slope. Remember, we're just going to use this point. So we just have our x1 and our y1. So we're going to get y minus -3, which is really plus, equals the slope -2, x minus 4. And just like we did last time, we can go ahead and distribute. So we'll get y plus 3 equals -2x plus 8. Then we got one more step to get to get y by itself. We just got to move that plus 3 over by subtracting 3 on both sides, and we get y equals -2x plus 5. And there you go. Okay, the next one, find the intercepts. Well, we know an x-intercept is when y is 0. So we're going to plug in a 0 for our y, which ultimately ends up becoming 0, so we don't really need this. So your only step is to divide both sides by 2. And your x-intercept is 16. Now your y-intercept is when x is 0. So we're going to do the same thing. But instead of replacing y with 0, now it's x. So 2 times 0 minus 8y equals 32. 2 times 0 ends up being 0, so we don't need this over here. We will divide both sides by -8, and y equals -4. So now we have our x and y-intercept. Okay, number 9, the weight in pounds of a newborn baby T months after birth can be, I'm going to highlight this T months after birth, can be modeled by the equation W equals 1.5 T plus 10. What is the slope? I'm going to ask what is the slope of the equation and what is its interpretation in the context of the problem? So we're looking at the weight. I'm going to highlight the weight in pounds and then months. So I'm going to label my x and y. So we have the weight and we have the months. Of course, time will always be x. Y will be whatever else there is. Remember, your slope is always the y over the x or the y per the x. So your slope in this case, in the context, would be the weight per month. And the weight is going to be measured in pounds, which might help us, so I'll just make a quick note there. Now, they don't just want the interpretation, but they also want the slope. So we can find the slope in the problem right next to our variable. So our slope is going to be 1.5. So what it looks like is that it's 1.5 pounds per month. And this is, of course, talking about the baby's weight. So in parentheses, I'll put baby weight. So the baby's weight is changing by a positive 1.5 pounds per month, so it must be gaining about 1.5 pounds every month. Okay. Number 10 says 3 friends, Brody, Avery, and Khalil, are saving different amounts of money each week. Brody started with $27 and added $20 every week. Avery's savings are represented by the table below, and Khalil's savings are represented by the graph below. Who saved the most money per week? Who saved the least? Okay, we should definitely look at Brody because it's asking about how much money they save per week, and he saved $20 every week. Okay, so maybe I'll make a note of that. So Brody was $20 per week. Let's look at Avery. So in 4 weeks, Avery saved $20. Okay, so if it's $20 per 4 weeks, then it must be $5 per 1 week. So all I did was find the slope here. I did my change in y over change in x. And we know that that's dollars per week, just based off of the units that they already gave us. So Avery is $5. And let's look at Khalil. We could just use the 2 points that they gave us. So if it looks like in 2 weeks, Khalil saved $30. So if that's $30 in 2 weeks, then that must be 30 divided by 2 would be $15 per week. So Khalil is $15. So now we can just label the most to the least. So Brody was the most and Avery was the least with $5. And then Khalil was just in the middle. And then for the last one, remember the domain are your possible x values. I'm going to write it using both notations. So your x value, so let's look at the leftmost point on this graph. It is closed and it is at -8. Now since it's closed, we can include it, so we're going to put a bracket. The rightmost point on this graph is right here, and that's when x is 0. And again, it's a closed circle, so we'll put a bracket. Now we can also write this using inequality notation. Again, your -8 goes on the left. We can include it so it gets an or equal to sign. And the highest is 0, so we put that on the right-hand side with an or equal to sign. Now the range are your possible y values. So we're going to start down to up. So down here we have an open circle. That's our lowest point, is an open circle at -4. So I'm going to put -4 with a parenthesis because we can't include it, it's open. Now the highest points on the graph, these are both, I guess, the highest point, but they're both at 6. And since they're closed and on the line, they're going to get a bracket. Now again, we can write this using inequality notation. We're using y now instead of x. The lowest is -4, the highest is 6, and the 6 gets an or equal to sign because it's on the line and we can include it. And that's the review.